A mass of 10 kilograms is suspended vertically by a rope of length 5 meter from the roof. A force of 30 Newton is applied at the middle point. The angle made by the upper half of the rope with the vertical is theta is equal to tan inverse. Okay. So as usual, since that some of you have asked for, to make a generic flowchart of how to solve the problem. See, actually, such a flowchart doesn't exist. I mean, it wouldn't make sense that you try to put every question into one single framework. No. So the demand of the question would vary, especially when it comes to mechanics. It would be varying. See, to put it simple, every question is unique. Okay, although there are similar questions, most of them are unique. The demand is the demand of, or rather the test, what they actually want to do from the question on your knowledge will be different. However, to my best, I have made a flowchart here. Maybe you can make use of this. So first things would be to visualize it. And how do we visualize? We draw a diagram. There's rope here, equal division by middle point, 2.5 to 0.5, forces acting. Next, we will make a frame of reference, and most usually I prefer inertial frame of reference or non-accelerating frame of reference. So we will see things from a observer standing away from the frame here. Okay, so done, frame of reference done. Now which system are we going to study? So we have the wall here. We will choose the vertical as the main direction here. Why are you choosing the vertical? Because the question is based on the angle of made up by the upper half with the vertical is theta. So this angle is given to us as theta. So we'll use, usually we use horizontal to resolve the components. Here we use vertical to resolve the components. And then we have to isolate the body, sigma f, sigma I, and solve. Now how do we isolate the body? So say this is the rope here. I'll take one portion, one small element of this. What do I mean by this? That's important. So let's say this is a very small element within the rope, right? Very small element within the rope. Very small element within the rope, and that small element, I have drawn the free body diagram of it. Now what are the various forces acting on this small element? Yes, we know that the very first force will be the force of gravitation, which will result in mg. Since this is a midpoint, there is another force acting on it, F, which is given to us as 30 Newton. And we know that since this is a rope that which is attached to a wall, there would definitely be what acting on it? There would be the force of tension acting on it. And tension, we know tension is a force which will always act away from the point of contact. So tension is a force which will always act away from the point of contact, right? Yeah, so now you may wonder how to resolve tension, because there is an angle given to us as theta. So let's move into that part of the question. So I will resolve tension into two components, T sine theta, the horizontal component, and the T cos theta, the vertical component. How? Let's try to understand that part as well. So let's say if this is the tension originating from this point acting away from the point of contact, this is tension. This can be resolved into two components. One is the vertical component like this, and then we have the horizontal component. Oops, give me a minute, sorry. Yes, and then we have the horizontal component like this. Okay, and okay, let me just repeat that one more time. So when we have tension acting away from the point of contact, it can be resolved into two components. One, the vertical component, right, and the other would be the horizontal component, right, which is this component over here. So sorry, give me a minute. this component. Now, this component over here, see, as we know that the displacing a vector will not change its property, we can take this vector and keep it over anywhere in this plane and it will show the same property. So instead of keeping it over here, I'll bring it down like this. Okay, and therefore we can say that the vector tension vector T is resolved into two components, one T cos theta and the other T sin theta. Okay, and now how do we label these? Okay, now you might be wondering, how did we label these components, right? Let us understand that part as well. So for that we need to draw the triangle. What is the triangle over here? This is the triangle. Let's call this triangle as ABC. And what is this angle? Theta. Now tell me what is sin theta? Sin theta is opposite, which is AC, by hypotenuse, which is AB. What is AC? Therefore, what is AC? AC is equal to AB sin theta, right? Similarly, what is cos theta? Cos theta is equal to BC by hypotenuse, which is AB. And therefore, what is BC? Therefore, BC is actually equal to AB cos theta, right? Now, what is AB? AB is represented by the tension T. So, these two can be replaced as T sin theta and T cos theta. Therefore, the components as T cos theta, which is BC, and AC, which is T sin theta. Okay, I hope that makes sense. Right, so now what we'll do is we'll understand the equilibrium. So the next step is to understand the equilibrium. And how do we do that? See, if the body is in equilibrium, which according to this case, sigma Fy should be equal to 0 and sigma Fx equal to 0. And if sigma Fy is equal to 0, what does it mean? It means that, now it actually means that forces in the upward direction are equal to forces in the downward direction. What does sigma Fx is equal to 0 implies? It implies that forces in the left direction is equal to forces in the right direction, right? So what are the forces in the up direction? Let's see. The forces in the up direction are T cos theta. What are forces in the down direction? It is mg equal to mg. Now sigma Fx is equal to 0 implies forces along the left direction. What are the forces in the left direction? T sin theta is equal to forces along the right direction. What are the forces along the right direction? It is equal to F. So it is equal to F. Now what I'll do is I will bring these two equations close like this and then divide them. So dividing the LHS alone, T by T is 1, sin theta by cos theta is tan theta, F by mg is, F is given to us as 30 Newton, so 30 by mg, which is 30 by 10 into 10, right? And now what is tan theta is equal to? So 30 by 10 is 3 by 10, which is 3 10 to the power minus 1. And if we come back to the question, it is given to us as it is 3 into 10 to the power minus 1. Therefore, the value of x is 3. Okay. Yeah. So that's question for you. Let's move on to the next one. Okay. Now we have questions based on friction.